This is Andrey. He's working at JetBrains, and you might know of other product they've developed called IntelliJ IDEA. And he's here to talk about the new JVM-based language that he's developing right now.
Thank you very much. Thanks everyone for coming, and thanks Bogdan for organizing this. It's my great pleasure to talk here. So today I'm telling you about Project Kotlin. This is, as said already, a new modern statically typed object-oriented language, primarily for JVM, but currently JVM is not the only platform we work on. And I'll give something like an introductory talk here, but I would really like to make this session as interactive as possible. So please go ahead and ask questions as soon as you have them. And so if we get off my track, it's okay. Just forgive me for not having slides for those things, and we'll discuss what you like. So the biggest thing about starting any interesting project is why you want to start it, right? And so a language here is maybe very much like any other project, and maybe very different from any other project because the language sits very low on the tool stack which a programmer uses. So of course there is a motivation I can tell you about, but actually there is an interesting observation that makes whatever I say about my motivation not very relevant. The observation is that very many people create languages all the time, but recently this tendency changed a lot. So if maybe 15 years ago, the most new languages were by enthusiasts or researchers, today very many new languages come from industry. There are big vendors behind many new language initiatives in the last maybe 5 years. And Google being one of the very bright representatives. So when we started thinking about Kotlin, it was 2 years ago, we primarily targeted JVM. And on the JVM, there were two alternatives then. It was, well, two viable alternatives were Groovy and Scala. And basically, that was the landscape we adjusted against. But in a year from then, when we announced the project, we were not alone. So the same year, in 4 months actually, there were 4 projects by different companies announced in total for the JVM. And the interesting thing is that the motivational part of all the projects was almost the same. We want a better language on our awesome platform. So, and these are by real industrial vendors, like our biggest competitor now is Red Hat, which is, you know, a giant. So, why people want a new language on the JVM? The answer is actually quite funny. It's because Java is the great platform. People even write those books, you know, say Java rules on the cover. And Java does rule. As a platform, since 1995, it was steadily developing, and every year bringing more and more interesting things, new libraries, new frameworks, improvements to the virtual machine. So today we have a really good platform that serves very many purposes very well. So it runs on servers, it runs on some desktops, it runs mobile with Android, so on and so forth. So it serves very many people. But the thing is that all that is about the platform. And the language is a different story here, because designed in 1995, today maybe it is not 1995 design yet, but it's 1998 design probably. And we are in 2010s already, right? So the state of the art in the understanding what a programming language can do for you is far ahead what we have in mainstream languages. And it's not only Java, by the way, but Java is a very good example here. So the urge to fix that is very natural, and people are trying to fix Java. And I'm myself volunteering on an expert group for Project Lambda, where we try to squeeze this very, very neat thing into Java, but it's been 6 years and it's not there yet. It's not because we are too lazy. I mean, I'm lazy, definitely. But people at Oracle are not, and they're really working hard on that, and it's not there because it's a very hard problem to squeeze something really different into this design, because the design just doesn't like it. It rejects the new thing. So this is why the idea of having a new language is a pretty legitimate one, actually. So what kind of language do we want? It's very simple. We want a modern language for industry. So basically, we want, when we decipher these two words, And what modern stands for is basically the modern understanding of expressivity. So you want your code to be kind of corresponding to what you think it should be. And the biggest problem there is that you don't want to say more than you actually need to communicate to another person reading the program. And the person is a very important thing here. So if you take Java or C++ or many other mainstream languages, you have to tell the compiler so much that people reading that don't need that much information. You definitely do not want to strip everything away, but very many things do not need to be told to people, but have to be told to the compiler. So one source of your verbosity in the code is that your compiler is stupid. And that is a technical problem. You can fix it, actually. There are many techniques there, type inference, stuff like that. So this is one source, which is really an engineering problem you can fix right away. And another problem is more fundamental. It's you're repeating yourself over and over again because your language does not allow you to abstract this idea over and put it into the library. So this is about having the right abstractions, the right means of abstraction in the language that make it possible to abstract over some complex pattern or something and use it as a library call. So these are two things we want: right abstractions and smart compiler. And the industrial setting actually makes it interesting to do because you can think about very many interesting languages that are not applicable in industry at all, just because of the specific setting we have. So here's Joe. He's not a Googler. He's working in hardcore core industry. No fun at all. It's just hard work. So Joe's environment is that he has a 2-something million lines of code project, which is 10 years old and maintained by 30 people, and none of them love their job, but this is not the point. The point is that it's a huge thing, and you have to basically maintain it more than you actually write new things, so you read more code than you write. And probably this even holds in Google and everywhere else. Right, so the point is that it is much more important to make your language readable than to make it easy to express things. It should be easy to communicate, not to express, actually. And this is a constraint, because if you think about very powerful techniques like metaprogramming, for example, this takes so much away from the reader's eyes, you cannot afford that. For example, our biggest problem with Scala, when we tried Scala at JetBrains, was that Scala relies so much on the concept of implicits, where you have a bunch of code, and it works, and you don't know why. Because it's so much going on behind the scenes, and it's not in the text of the program. You don't even know where are the points where the implicits are called. So you have no means to suspect which particular call to inspect. And all you actually are left with is take a debugger and just step through all that and figure out what's coming in from where. So you can't. So fighting boilerplate, you can't afford just removing all the details from the program. You have to find some middle ground there. Are pretty much relevant. I'm telling you that, well, JetBrains has enough expertise for programming languages, and we did try different other languages, but they didn't work for us. Feel free to ask questions about that and any other questions on motivation you would like to ask now. Sorry about that. Okay. So, yeah, that was a pity. Hello there. It is a talk in Kotlin by me. Thank you very much for your attention. So, I've done my motivation, and the question I get after that is, what is this third language here that we tried and didn't work for us? We actually didn't try it. It's a new language. It's our biggest competitor after Scala today. It's a language by Red Hat, which is also statically typed and object-oriented and tries to fix Java in a way. I think the biggest difference between Kotlin and Selenium is that Selenium's approach is, okay, we have a language, and we want to redo all the platform. Like, no JDK, you just take our own classes, our own class loading strategies, our own execution environment over JVM, and you work there. So it's basically making it pretty hard to interrupt with the existing code base. And my setting, say JetBrains, and I think many people's setting would be, you want a language that lets you take your huge Java code base that you already have and put new things in the new language, keeping the old things in Java without having to do anything other than setting up the build, basically. So this is the huge difference between the Kotlin attitude and, say, Selenium attitude and many other competitor projects. Okay, so to summarize, the design goals behind Kotlin are being environment friendly, where environment is whatever platform you run on. So we started with JVM, but we actually now compile to JavaScript and plan to compile to native platform. So whatever platform you run at, you want to be environment friendly in the sense that you're compatible with everything available on the platform already. And you want to be productive with that language. This means you want to be expressive but type safe, concise but fast. And just look at this and figure why many languages don't fit. Because some of these are missing from very many settings. We want it to be learnable, of course. So our own outlook is that you need tools. So how many people are using Vim daily here? Emacs? Okay, actually I thought it would be more like Vim against Emacs in here, but it's actually looks like it's Vim against more like modern IDEs. Vim is very, very modern. So the thing is that, so we are an IDE company, so everyone uses a powerful IDE in JetBrains, and we know that many other people like powerful IDEs. And I personally admire people who use text editors for doing code, because if you use Vim for large-scale coding, this means you're a Jedi. And this is cool. But the problem is that if I'm running my whatever software shop somewhere not here, it will be quite expensive for me to hire you, for example. Just costs too much money. It's, of course, you do not charge for using Vim. You charge for what enables you to use Vim. And this is why we believe that people in general need tools, need very smart IDEs and stuff like that. So our third requirement of the language is tool support. So before I get to the examples, here's my timeline. We started 2 years ago, and now we're at this M2 stage here. After a couple of milestones, we'll be in beta, which will mean that compiler does not crash too often. And at this point, we're starting to use the language of JetBrains extensively. Currently, it's used in production a little bit, and we'll proceed to massive use. And after we validate it this way, we specify and release the first version. And since February, it's open source. So if you're interested in anything about it, just check out the code, fix a bug if you like, submit us a pull request, and join us in making the future better. All right, any questions here? Then the boring part is over. Yeah, sure. Go ahead.
You will be addressing problems in Java in the syntax design. There are also many problems in the class libraries. Well-known problems. So when you say you will be as compatible as it can be, in contrast to Iterator, if you're trying to do a fresh start, fresh Sabbath as well. What do you think of that? Provide new class libraries, or just rely completely on Java?
Okay, the question is, what are you going to do with those problems in the Java libraries that are there? Will it fix it in your standard library? So the thing is, we'll do as much as we can without breaking compatibility. So if we do not need to disable your ways of communicating with the old code, we'll try to fix that. And actually, there are very interesting challenges there because, for example, if you want to use Java's collections, you want to make it better than Java because Java's collections are invariant classes. You cannot, your list of objects is not compatible with a list of strings. You cannot assign a list of strings to a list of objects, and this is legitimate because you could break it otherwise. But if you could have a read-only list, that would work. But Java doesn't have the notion that enables you to do that. And we want to introduce that notion without actually going away from Java's collections. This is one thing we are going to do. And but this is a particular solution for collections as such. So this does not scale on the whole library. So it will be point by point personal decisions on every question there. Okay, should I proceed to the examples? All right. So I'll try to go as quick as possible, not to bore you with the uninteresting stuff. So here is the hello world, which is probably obvious. So please note two things. One thing is that code is organized into packages, and a function can sit under a package. So in the Java world, you cannot have a function outside a class. And here we get it back to, say, C++ old times or whatever, good times, where a function can actually sit under a package. And the rest is pretty obvious. So this is a type, a generic type. Yeah, and you should have fun, of course. Any questions here?
Where does print
Printline is a standard function. So there are implicitly imported standard things. And this one is defined in the Kotlin IO package, so you can actually navigate to the source. And internally, it uses the Java system class. We'll get back to the question mark a little later. More questions? Array is invariant, because it is correct. Oh. That wouldn't be too much of Java incompatibility, because so you cannot pass, if you have an array of objects as a parameter somewhere in Kotlin, you cannot pass an array of strings there. But this is not a Java incompatibility. Because if you have a Java method that takes an array of objects, we actually load it into Kotlin in such a way that this parameter is covariantly projected, so that it actually looks like it is an array of !extend string in Java terms. It's a little different in Kotlin. So it is not an incompatibility. It's a mild fix that compensates for a problem we have in Java. More questions? Okay. So yeah, one thing, just to illustrate what we are fighting. So here is a bunch of Java code. The question is what it does. What does it do? Sorry. There is, yeah, nothing. Thank you very much. This code does nothing and does not fit on the screen. So this is the problem we're trying to solve here. So yeah, so here is the Kotlin's version of that. This is not perfect Kotlin. I'll fix it a little bit later. So here's a class with 3 constructor parameters. So you define your constructor right in the class header here. And these vals are read-only properties. So these are just fields with getters right away. And we just assign the constructor parameters to these getters. And this makes a little more sense than Java, but still it's not perfect because you have to repeat yourself with those types here and with these names mentioned 3 times each, right? So I can fix that by doing this. I just call them all vals right in the constructor parameter list. This is what's called constructor parameters as properties. So basically, you want to say, I have a bunch of data here. This is what you do. You say, my constructor parameter is a property right away, and this one as well, and this one as well. And this basically generates that Java class we had before. So all the getters are there, the constructor body is there, the fields are there behind the scenes, and the toString is this concise. So you can use what we call string interpolation. Inside the string, literally, you can mention your variables, just to be put in there. Very useful for debugging.
Does Kotlin know that this is now itself immutable?
Not yet. Yeah, so the story about immutable objects is a little more complicated. So we could actually figure that as these classes are immutable, and these fields, these properties are immutable, we could figure that the whole class is immutable. But that would require a lot of annotation, because, well, these classes are standard. They could be annotated out of the box. But if something else is not standard, you'd have to somehow denote the immutability. Otherwise, the compiler wouldn't be able to check that modularly. So I think when we demand immutability, we need to put an annotation on the class. And it's actually a very interesting story about, so people keep asking me if our language supports multi-threading in any way. So the only way we're going to support multi-threading in is providing immutable data. Because otherwise, I don't know how to do that. I can support one model of multi-threading, like actors, or software transactional memory, or Java-style locking, or maybe something else, but there will be only one model, which is anyway not the best one. Because the best one is to fix our hardware, actually, not to provide any means on the software level. So we do not wire any model of multi-threading into the language. We provide libraries for that. And from the language perspective, we provide only immutable data that facilitates nice communication between your threads. Any questions here? Yes. Yes. So a property, as well as a function, can be overridden by another property. And of course, you can customize your accessors here. So not in the constructor, of course, but when you define a property, you can provide a custom getter or a custom setter. Go ahead.
Can I provide a second constructor for this?
Oh, this is a nice question. The answer is no. You cannot have multiple constructors. But why are you asking? Why do you need the second constructor?
Okay, make default bits.
Right. So the maybe 90% of default of overloaded constructors in Java, for example, or maybe in other languages too, is for providing default values for constructor arguments. And this is what you can do here. Probably 0 is not too good. It will be 18. So if I want this property, this constructor parameter, to be by default have some value and to be not passed on the call side. So if I want to omit this 18 here, I can just mention it here, and it will be passed automatically to my constructor calls. So this eliminates maybe 80 to 90% of the need for multiple constructors. And the rest of that need is evil anyway. Because if you have differently, significantly differently structured initialization logic, it means that you have many classes, not one. Yes, and actually, one other fraction is covered by factory methods. Yeah.
Where is the initialization method here? So if I want to do something at construction.
Yeah, sure. You just put an anonymous initializer. So whatever you probably don't do much with this class because it's just a pojo. But if you want some code here, you can just put it inside the class body. So basically, the class body is the body of the primary constructor over here. More questions? Okay, you have named arguments, so you can do it this way here. I have first name equals John, last name equals Doe, and the age is not there. So on the call side, you can specify only those arguments you like using names, and of course you can reorder the names and specify only those you need. More questions?
Does it have any keyword arguments like in Python?
I think this is the closest you can get to keyword arguments because it's a static language. So you cannot do like a map, right? Because this has to be statically checked somehow. Go ahead.
If you haven't specified a value, do they get the 0 null?
Nope. No defaults whatsoever. So this is a kind of implicitness we're trying to fight actually, and I'll get to nulls a little later. That's an interesting point. Okay. Yes, we do, and here, yeah. So this is an unfixed issue in Kotlin. We'll fix it definitely. So it will actually say public override function. But currently, for toString individually, it is so because toString is not available on the. So it's not a member of the root class. So the root class currently is empty. There is nothing there, And toString is something coming from the outside by convention, and this is wrong, and we'll fix it. Okay, let me get to some more interesting things. And here is my string iterator example. So this is a for loop in Kotlin. We don't call it enhanced for loop because it doesn't make any sense to have an unenhanced for loop. So this is not possible in Java because Java's string is not an iterable, and Java's for only accepts iterables in this position, iterables or arrays. But in Kotlin it is possible, and not because strings are iterable in Kotlin. Actually, strings are just Java strings in Kotlin. But this is because the string has this iterator method in Kotlin. And for can iterate over anything that has the iterator method by convention. Now the question is, okay, you use Java strings, but Java strings don't have the iterator method. How does it get there? The answer is this is something called an extension function. So if I navigate to the source, here it is. The declaration of this function says that it is a function for the receiver of type string called iterator and returning some obvious implementation of the iterator. So actually in the bytecode, this is a static method in a utility class basically, which takes one argument of type string. So it's all statically dispatched. We didn't touch the actual string class. But from the syntactical point of view and from the conventions point of view, you have a new method on the string class. And you can call it in any context it is demanded. For example, in the for loop. Any questions on this? Okay, so the question is, what happens? So where do you see those extensions, and what happens if there are conflicts? So this extension here in my example is just defined in the same file, and the relevant part is that it's in the same package. So by default, your extension is visible in the same package you are in. Otherwise, you have to import it explicitly. So you say import and the name of the extension. If you import two extensions that are conflicting, you get an error on the call side. So when you try to call iterator and there are two iterators applicable at this point, you just have an overload resolution ambiguity, and you, for example, can rename one of them on the import to disambiguate. Yeah, so and these are purely static, so you don't have any problems like somebody coming in at runtime and adding a new extension. This just does not happen. More questions? Mm-hmm.
Can I use extensions to add properties?
You can use extensions to add properties as well. So there are extension functions and extension properties. I'll show one a little later. Oh, by the way, I can. No, because extensions are defined statically. The notion of overriding doesn't hold there. It's not applicable. You can overload them because this is a static mechanism. And answering your question about extension properties, so here is an example of how you use extensions to accommodate big decimals in the language. So you know that Java puzzler or whatever puzzler that subtracts 1.1 from 2 and gets not 0.9 but 0.8 and many nines. So this is worked around by using a class called big decimal in Java. And here is a Kotlin DSL for big decimal that enables creation from string literals with this BD extension property, and then enables minus on big decimal with an extension function. So here is my BD property. It is just a val with a string receiver that returns big decimal, and here is the custom getter that just creates a new instance of big decimal. We don't use the new keyword in Kotlin. This here refers, of course, to the string that was passed in as the argument. Questions here? Go ahead.
Extensions in other languages are criticized on the grounds that we go harder. Necessarily familiar with some of these extensions.
Yeah, so the question is, there is an opinion that extensions make your code less readable because you're not familiar with extensions provided by somebody else. So this may be a fair point, although I think that when we have to compare two things, being able to make existing classes nicer in this way, in a static way. This problem of maybe not knowing what the extension name means, I think I choose extensions because it's your code. You can actually see the docs for the extension function. And it actually, if you think about it in a broader setting, well, somebody could add a method to a class you're using. Well, maybe not to a library class, but still you're using a lot of classes that are maintained by your teammates. And well, somebody could add a method and then you just go there and read the code or read the comments. And this is what happens to the extensions, I think. Yeah, so I do not think that this is so much of a problem. But yeah, if you have arguments, please communicate them after the talk. It's very interesting. Thank you very much. The second thing here is this minus operator, which is, of course, not available for as a built-in thing. It's actually available by convention. So when you say a minus b, this actually means call a minus function that is callable on the left and takes the right as an argument. So if I navigate to the source of this here, this is what I have. This is my extension function called minus, just by convention. It should be this name minus. It takes another big decimal and actually just redirects to the built-in method, to the method of big decimal class. So this is how you make existing libraries play nice, even if the initial library design was not did not fit well with what you need from the library. Especially for really old classes, this may make a lot of sense. Yeah, so basically when you resolve the call of the extension, you take the receiver argument as one of the parameters, as a value to one of the parameters of the function. So it's normal overload resolution there, and if something was defined for the superclass, it's available on the subclasses. Right.
What are the reasons that you have separate keywords for the different operators instead of operator minus operator plus like in C++ or C++?
Thank you. So the question is, why don't we have the notion of operator instead of having named functions? So this is actually a matter of taste. Depends on what you want to reuse. So the initial point for doing this is that many existing classes, Java classes, already have some functions with the right names and right positions, and we could reuse that. But it may be a weak argument. So what we actually want to do now is to demand a special annotation on this function that says operator, fun, and then the rest, just not to alter the language syntax too much, because the question if that deserves a separate syntax construct is a very big question. I wouldn't like to add new things, but to restrict the usage of only intended functions, it's actually a good idea. More questions? Go ahead. Why do I import ArrayList? This is ArrayList. Good question. ArrayList by mistake, I think. I don't think it is needed here.
Would it ever be an error?
It will be a warning, not an error. Yeah, and the warning is not there yet, but it will be definitely. More questions? Go ahead.
Do you ever get control over operator precedence?
The question is if I can control the precedence of my operators. The answer is no. The table of the operator precedence is wired into the parser, which makes fewer strings of characters parsable by Kotlin, which is good.
Can the extension be seen from a Java class?
The question is if the extension can be seen by normal Java code. Yes, it can, but not as an extension function. It will be seen as a static function, as a utility function, like what you put in your string util class or whatever.
So what if I have some static method called Java class?
By default, you will see that as just as a top-level function in Kotlin. So you will be able to call it like minus of a comma b, and since we provide some means of annotating Java code to be nicer to Kotlin, you will be able to annotate that to be an extension function in Kotlin. Or you could write your wrapper function in Kotlin code, but that would be some overhead, of course. Okay, let me show some other nice DSL. So as we are talking about, oh no, this is too early for DSL, sorry. I'll show you this first. So here is an example about collections. People ask if we have literals for lists and maps, and the answer is no, because functions are good enough. So here is a piece of code that creates a list of users with 2 elements. Actually, this returns an array list, but later on it will be returning an immutable list. And now I want to filter this list, only take those users who are older than 30. And this is done in an obvious way. So I think in this audience, I don't need to introduce function literals or anonymous functions or lambda expressions. So this function called filter takes this lambda expression as a predicate for filtering. Any questions here? Oh, excuse me. It was too many. I recognize this question from here. Can I throw away those curly braces? The answer is no, but you can throw away the round braces. So you can do this. And the rule is if you have your lambda expression the last on your argument list, you can actually pass it outside the brackets. This can be very useful. I'll show you some examples later. More questions? Go ahead.
We don't need to specify the type here?
You don't have to specify the type for this parameter here because it can be inferred from the context. So here we have quite a bunch of type inference going on. So first of all, you don't specify the type of this variable, although it's there actually inferred from the right-hand side. And here you can the compiler infers the type of the U from the definition of this filter. You cannot take this anonymous block as it is and assign it to a variable without providing any types. You have to put types there.
Can you have
sorry, no. So actually, this question generalizes as do you have any kind of global type inference in your language? The answer is no, because I used to read quite a bit of Haskell, and the thing is that okay, Haskell is this powerful global type inference. But reasonable people never use it because if you don't put types in a Haskell program, you can't read it. So the point is, why bother doing that complex thing over your language if it's not usable anyway? Although I like the algorithm, it's beautiful. More questions, please. Is that okay? Good. So now we have, so of course, this is a normal array list, and this is an extension function. And I'll show you the definition. It is pretty straightforward, actually. So we have a generic function on collection of t's, taking a predicate over t. Let me scroll. Collection, it could be iterable, actually. Yeah, so in this example, it's collection, just because I made it up. So this is not a library function. It's just my example here. So the predicate is a function from t to Boolean, and we return a list of t's. So we have built-in function types in the language, which is a huge difference from what we're doing for Java now. Without introducing new kind of types to the language, we're putting just lambda expressions, which is an interesting solution, very Java style. Questions here? Not yet. So the question is, if we have list comprehensions or collection comprehensions like in Scala, currently we do not have that, but we are aiming at having something like that. So it basically amounts to if we are going to have something like a yield operator from Python or from C# or from Scala. Probably yes. The question is how you make it better, because the Scala's way is very slow. So we want something more performant and as flexible as possible. All right, now let's do something. Let's push this idea of higher order functions plus extension functions to a little bit of an extreme and get something funny out of it. So here is, I don't know how many people here did any swing in their lives. I hope you didn't suffer from that too much. But this is swing wrapped into a little bit of Kotlin. So what this actually does, I'll just run it. So it creates a window with a text area and 2 buttons. And the interesting property of that program is that if my resolution wasn't so low, it would actually fit on the screen. So it's just 2 more lines there. So the thing is that we have something very much like a declarative program here that defines the structure of a window. And this is using pure swing plus a bunch of extension functions. So I'm creating a JFrame. This is basically a factory method I wrote myself. A JFrame with this title, and this is, so what are these curly braces here? Actually, the closing one is down there. So what is this? Well, actually, it's, of course, it's a Lambda expression. Yeah, so it's a Lambda expression actually passed outside the parameter list, as I showed you before. So basically, instead of doing this, I could say demo, comma, Lambda expression, and then close this later on, but I can't afford using it this way. So this is a Lambda expression passed to this function. And if we look at the definition of this function, it will be interesting, because it takes everything together, having, I'll just break the line here. So here's my JFrame function. The first argument is easy, it's a string, and the second one is interesting. So have a look at this function type here. What is it? Well, unit is void, of course, but what is the function type? So what kind of function do we have here? Right, so this is an extension function to JFrame being passed as a first-class value. And inside here, it's absolutely nothing interesting, because here we have the JFrame. We call this extension function in this syntax. Nobody cares, actually, and we return the frame. But if we return back to the calling site, here is my extension function, right? And what being an extension means here, it means that there is a this inside here. So my calls here are actually this dot height and this dot width, which means that the compiler is basically tracking the context for me. So these height, width, and center and south are for JFrame, but this west is already for JPanel because it sits inside another extension function. And this actually enables me to create this idea of declarative DSL with tracking context without any special language constructs. It's only extensions plus function literals and function types. That's it. Nothing special. No object initializers, no special syntax for assigning to properties, no nothing. It's just code inside a function literal. Questions here, it should not be all obvious. Yes. So if you say something that is not available for JPanel but is available for JFrame, unfortunately you get access to that. So for example, height is available on JPanel as well. So if you say height here, it will be height of the JPanel. But if you think about something that is not available in JPanel, I don't remember what it is. Default close operation. Yeah, default close operation will be from JFrame, just because the resolution works so that if in this object it's not available, you go outside because it's a closure. You're taking what was available from the outside. Actually, we're thinking about some ways of blocking the scope from getting into this, but the question is how you make it not too ugly, because it's this is already something you want to hack to tweak your DSLs, and it's questionable whether you want it actually, but we're thinking about it. The interesting thing about this feature is that dynamic languages are very proud of having something like this. Like in Groovy, this idea of builders is very big, and it's purely a dynamic concept there because the context is being tracked dynamically. And what we have here, with combining very simple features actually, is purely static, thus safe and performant implementation of what before that could be only done dynamically. well, a nice toy anyway. Another example of the same technique, which is actually more relevant than building swing windows, is building HTML or whatever XML. So here I define a bunch of functions that correspond to HTML tags. And here's my HTML with the table inside and rows and columns inside the table. And I can even generate many rows for the table with a normal for loop because this all is code. So I can do something like I do in, say, JSP or some nicer generation frameworks in pure Kotlin. I can't decrease my font size. Sorry about that. Never mind. So the structure of these functions is all the same as it was before, right? So this is taking an extension function to the HTML class, and this for table, so on and so forth. And every time you call a TR, it actually adds a new row to the table, which is outside here, because TR is defined here like this. So TR is an extension function on table. So as a receiver, it will actually take a table that was somewhere outside. This is probably the only presence of an implicit concept in Kotlin and the most complicated thing in Kotlin, which we do not get rid of because it's giving us a lot of power. Questions here? Oh, double exclamation mark. I'll get to it in a second. Okay. So now let's forget about those interesting things and get down to hardcore work. My hardcore work is something like this. I'm creating a file object, call a list files, and take its length here. And then I just want to print it. This is a very bad program. People who are not doing Java all the time may not remember this, but the thing is that this list files tends to return you null all over the place. Because if this test is not a file, does not exist, it will be null. If test is not a directory, list files, which is supposed to give you all the children, will be null. It's not an empty list, it's null. So when I say list files at length, I just get a null pointer exception. And there are, of course, very many things like that all over the place. And this makes people in hardcore industry, instead of having fun, write those null checks everywhere because they don't know where nulls come from. And we aimed at fixing that problem a little bit by introducing the idea of nullable types in the language. So our type system actually has the notion of a nullable type. So if you have this file, .list files in Kotlin, it actually has a funny type with a bunch of question marks. Here is the type. It's actually a nullable array of nullable files. So the question mark after a type means that this type can hold null. Otherwise, if there is no question mark, it means that there may not be any nulls as values. So this array, the args array, is not null itself and holds no null inside. And this array may be null itself and may hold nulls as members. Now, so what does this mean? It means that if I want to call files.size here, my files.size does not compile because the compiler complains about dereferencing and potentially null pointer. And this is just not allowed. What you're supposed to do, there are many ways to work around it, and one of them being double exclamation mark, which is an intendedly ugly way to say, okay, forget that. I know it won't be null. Just get away. And it will throw a null pointer exception if files is null. But this is not a good way. The intended good way is to say, if files is not null, just access the member, and that's it. The compiler can learn from your checks that your variable cannot be null because it just checked for that. And under this check, it's legitimate to make it reference. Outside this if, it won't be. So the thing is that this is what we call flow-based typing. So the compiler learns from what you wrote, and basically just lets you do whatever you like if it's safe. Questions here? Go ahead. Initialization for nullable types is okay. Can you clarify the question?
So if you're in a constructor, you have to know it's not fully constructed, you bet it somewhere else.
Great question. So the question is, what do I do if I have a non-null field in a class and the field is not yet initialized? The thing is that this is the problem very hard to solve, and we do not do anything about it yet. There is very little hope that we can fix it somehow, but most likely it will be just a hole in the types system, because it's very hard to track initialization logic in general, because you can call methods and do stuff like that that compiler cannot keep track of. But there is a little hope that we will do something about it. Thank you for the question. You had another one. Okay, the question is, can I create a method like assert not null? Actually, this is assert not null, basically.
Yeah, I mean, this method is supposed to do something like throw and run things.
Okay. Yeah, so the answer is, of course you can, but the question is, will the compiler actually learn that the files variable is not null after that? So this is something not implemented yet, but we're going to do that. We'll have something called inline functions. An inline function is not a function. Normally, it's inlined on the call side. Otherwise, it's type checked as a function, so it's not a macro in the C++ way. But as it is inlined, the type checker will know about everything going on in there, and you will do it that way.
Can you add an extension to all nullable types?
Yes. I can say fun t, which is any is the top type, t question mark dot foo. Do whatever. So this means that if I have any non-nullable type t, I can extend t question mark, which is guaranteed to be nullable, and extend it this way. The restriction is that we do whatever you can do without looping over a program. So we do not do any abstract interpretation as such, because it's not deterministic in the time. So what we do, we just keep track of all the variables while traversing the tree. So we're not doing any fixed point there. It's just one iteration over anything, and it's type safe in the sense that if we did not learn anything, we say it's nullable. Yeah, so this is what I told you about the extension, the inline function. So if that is an inline function, so not a function actually, you will have the analysis. Otherwise, you will not. And so this is the concept of nullable types, basically. And this flow-based typing, I think I have one more. A nullable type is a supertype of non-nullable. So you can assign one way. I think I have time for one more example, and it will be an evaluation of an arithmetic expression. We treat as kind of an interface, and here is a constant and a sum of two expressions. So I have a tree of objects like that, and I want to evaluate it to an int. Just normal school example. So this is how I do it in poor Kotlin. I have an expression, I want an int, I check if expression is num, I invent a new variable name, I cast, and then I access the value here. This is something I hate to do in Java and in many other languages, because this variable is completely useless. Of course, I could inline the cast, but it wouldn't make it much more readable. This is why in Kotlin, with the same concept as we had for nulls, we allow you to do this. If it's already num, use it as a num. You know that. So it's about making the compiler smart. Okay? I told you it's num already. Go ahead. Technically, it's actually inserting casts here. So a green variable means that it's automatically cast to something. And of course, you can do the same with with sum and with any other class. So this is how the this code looks for a very simple evaluator. And we reuse this idea in the our extended version of switch operator, which we call when. And here is what it looks like. So you can say, you can say when E is num, use it as a num. When it is a sum, use it as a sum. Otherwise, throw something. So this saves you a little bit of if, else, if, else, if, else, if, and makes it a little more clear. Otherwise, it's a normal, I would say, pattern matching operator. Maybe poor man's, but a pattern matching operator. So if one of the alternatives matches, you get the right-hand side and no matches further. And of course, the is check is not the only thing you can do here. You can match to an expression, which doesn't have to be a constant. So you can have, let me give you some example here, just not to val x is 1, val x is 1, and when x, you can say 15 and do something. You can say x plus 1. It won't probably match, but you can still do that. You can say even use some range checks and stuff like that, or negated range checks. So you have some reasonable power inside this, which covers most of the use cases. Plus, you can do is checks and have your flow-based typing. This is my last example. Any questions about examples?
We have some way to have a switch where you force the file time with all the possible values.
The question is, can I have a switch that actually makes sure that all the space of the values of x is covered? Well, yes. First of all, if you comment out this else here, you get an error. But this is a silly thing. So for enumerated types, we have this concept of enum classes, where the space of values of that class is known. We check that you actually covered everything. For numbers, it's Hilbert's 10th problem. It's undecidable. Sorry about that. We can't do that. Yes, so you can think about an enum class as a sealed trait, something that you know all the subclasses of. And for that, you can do that. Yes. More questions? There was some other question. The question is, do you have real pattern matching? The answer is currently we don't. So currently we have this poor man's pattern matching that instead of binding here actually gives you this E that you can access members of. And we are trying to get away without any pattern matching because it's a complex feature. So if it works without it, we'll be happy and we'll not implement it. Although it is designed there, so in the design documents we have the pattern matching specification, but I always hated it, and I'm trying to get away without it. Okay. Few words about exception handling. Exceptions are not checked. Otherwise, they are like any other exceptions, like managed exceptions in Java or in C#. That's it. Okay.
So you actually try to, or planning to implement part of the IORA?
The question is, are we going to bootstrap Kotlin? Yes, of course. So when we get to the beta stage, it's probably very soon, we'll start to use Kotlin in production at JetBrains, which means redoing Kotlin and doing parts of IntelliJ IDEA. So yes, of course we will. And this is my dream, you know? You have so much code and you rewrite it all from scratch. This is so cool. More questions? Trait is very, very much like an interface. You actually can implement methods inside traits, and this is the difference. So it's like Java interfaces plus method implementations right inside. So this is kind of close to what Java 8 will have, maybe at some point. this is multiple implementation inheritance in a restricted way. Traits cannot have state. And this is the huge thing. So when you have multiple implementation inheritance in, say, C++, the problem there is state, and actually not state as such, but initialization. Our traits have no state, thus no constructors, thus no problems with multiple inheritance. Okay. You just say, after this colon here, you can specify your constructor parameters right here. You can have only one base class, so it's not like a huge expression. It's just one of them is getting the arguments. Okay, I'm wrapping up here. So I didn't cover a lot of things, and you will find them on our homepage. You're welcome to contribute. So if you have spare time, and Google's policy allows that, come over to our bug tracker and submit patches, so on and so forth. And we're constantly looking for ideas. So if you have any interesting things to suggest, any critical notices, anything, please communicate them somehow from the forum, through through Twitter, whichever way you like. And if you have friends who are very fond of programming languages, tell them that we have a very interesting project, and we are constantly looking for people, of course, and for as well as contributors or employees.
So how finally is the syntax now? You're saying anything you've made decisions or you wouldn't consider changing at all?
I think we're pretty open to changing things. Before we release anything, I mean, beta is still not a fixed design. So the point is to try it in the wild and to fix things that are not working good. So we're willing to improve anything we have. Yeah, so all the suggestions on the syntax are very welcome. And I will really appreciate that help, because syntax is probably the most painful, although the least interesting part of the language. More questions? Go ahead.
What has been fairly fast implementation of closure and field? How powerful it is.
Agree?
For loops, no iterators.
Yeah, I would say
What are
that.
the issues with yield? Why is it so?
Okay, so the question is, why are we postponing yield? Basically, technically, the answer is that our language is imperative. So to implement yields efficiently, you need to do a CPS transform for your code, which in Java means that you actually emit a lot of objects. And this is problematic because you generate a lot of garbage, and this just does not meet any performance expectations. So the plan about yield is that we first do inline functions that I mentioned. So the point is that if you have a function that takes another function as an argument, you can inline them both. And this means no closure objects whatsoever. And that code is efficiently transformable for CPS. And then you can do yield on top of that feature. I mean, you can, before that, yield won't be performant, actually. And it makes mostly no sense to work out the whole power of yield without inline functions.
In Ruby, you take a closure as an argument, right?
Yes?
Yield is the same as calling, not call all that function. It's like calling that function.
Well, if you think about it, what yield does, it puts your value inside some collection and then proceeds from the point it was in the execution, right? So this actually means that there is some transformation of the code going on behind the scenes. Because to proceed from the point where you were, it means you either had to somehow transform your code to pass the collection to put your things into the code, or you had to transform the code so that you can so that it's an automaton and you can stop it and then proceed from that point on.
You can have closures.
Right. Okay. Yes.
You can call it anytime.
Yes. But if you just use closures there, it means that you either create many closures behind the scenes, and these are objects that cost, or you make your users create those objects explicitly, and this is just huge code. Yeah, so the point there is only performance. Of course, it's doable, but it's mostly pointless. So as Scala shows, you have lots of performance problems with for in Scala just because it emits so many objects. So this is what we're trying to avoid, and this is why we are postponing the implementation of the yield. That's it. Go ahead.
One of the things that drew me, well, no, one of the things that made me like Java eventually is large-scale refactoring performance and the reliability of this. Now,
Yes.
Some of the newer languages, and I say things like Go, seem to have not helped this. Because in Go you have these implicit interfaces which you can't bend over calling you. Is one of the design goals of Kotlin to support the same sort of set of refactoring operations as Java already does?
Yeah. So our environment is that we have, so around me, I have like 100 developers who use IntelliJ IDEA daily with Java. If I want to migrate them on anything that cannot do a global refactoring, they just wouldn't do it. So yes, fortunately, we have people who did the IDEs, huge IDEs for Java on the design team. So if anybody proposes anything that wouldn't work in that scale, they just say, guys, sorry, it's not an option.
So there's no implicit interface. There's no none of this.
No.
Duct typing or anything like that.
No. So there will be one thing. We will have what we call a dynamic type. This is something you can say, call anything on. But there's an explicit thing. So if part of your code is dynamic, you cannot rely on any refactoring there, and this is your intention. But this is actually supposed to be something in the corner because you need it for, say, JavaScript interoperability. You need it for maybe some dynamic frameworks instead of reflection, for example, many things like that. But that you never refactored anyway.
I noticed that all your functions are actually final.
Yes, that's correct. Okay, so what's about mocking? Good question. First of all, I don't believe in mocking classes. Mocking classes never works. Mocking interfaces does. So in a trait, everything is open by default, of course. So in classes, yes, we took this. Actually, this is something we might reconsider at some point, because the story was that we started with the full model of multiple inheritance in the language, and there were a lot of associated costs with with virtual things and classes you can inherit from. So we tried to minimize the number of those open entities by making them actually final by default. But we couldn't take over multiple inheritance. It's not solvable in any good way. So we took the state out and we separated classes and traits. But that decision of making everything final by default is still there because, well, this is what books tell us, right? You have to design for inheritance, so by default, you should be able to override that. It is an arguable point. I'm not sure which way is better. I definitely do not believe in mocking classes. I do not like that code that hacks all over Swing with overriding some protected things that were not supposed to be overridden, and by breaking everything eventually. So I'm not sure if we should actually reconsider that, but we might. So we'll actually just gather some feedback from people and see if that's a huge bait, we just remove it.
Just to do we have go on.
About tests, by the way, there is interesting thing about tests. The plan for tests in Kotlin is that you'll have a special mode for compiling tests, where you have access to everything private and everything that you normally don't have access to. And there are questions about whether we can allow overriding there where no overriding is possible, but this is not clear. But at least for private things, you will have access to them. And it will be actually the code you're running, but just compiled with a little bit extra accessors in different places. If you have any feedback on that, I'll be very grateful. Because because this is not done yet and not tried out yet. It's a very good time to give feedback on that. More questions?
About compiler tools, do you plan to provide some information from compiler about the structure of the code to be able to analyze it either in the toolchain or in the program itself, like expressions and such?
I try to match what you're talking about to what we have. So there will be a few things. First of all, the compiler front end, so the type checker, is a reusable component. So you can actually take a bunch of code, analyze it, and get the AST out of it. This is what the IDE does, actually. It's one thing. Second thing, of course, you have your annotated bytecode. And for static analysis, actually, the bytecode is the best representation because this is how all the analysis actually work. Internally, everybody generates bytecode and analyzes that bytecode. It may be not that precise as Java bytecode, but still. Yes, so there is a third thing, compiler plugin architecture, where we aim at providing a stable API for the AST, where you're guaranteed to have this structure and be able to analyze it with standard things. But this is not there yet, of course, because the compiler is being refactored all the time. So we cannot guarantee the stability of that until we are done with the release, of course. But there is a plan to do something like that. I think we're a little bit over time, so thanks everybody for your attention. It was very interesting. If you have any more questions, come over and I'll answer them. Do I have anybody else in this room? Do we have to leave? Great, so if you have more questions, just approach me and I'll tell you everything. Thank you very much.